Please welcome Ron and Cortland.
Everyone, so I'm Ron. I'm State Safety Engineering Supervisor at GDOT. I'm here with Cortland, and we're talking about one of the many projects we've worked on managing friction demand for sharp curves through visibility and friction improvements. So I have three takeaways for you guys today, three things to leave with. The first is that we did a systemic project focused on rural roadway departures on sharp curves across the entire state for our state routes. Crash data, in addition to some proactive data sets related to curve information from the Georgia Tech Curve Information Extraction Tool, was used to help program these projects. And then finally, we used a data-driven approach to categorize all of these curves into 5 different risk levels. Those different risk levels have different types of countermeasures that we are used in those programming of the projects. So before we get started, much of research has been done to be able to enable this kind of analysis. And we hope that everyone in this room, if you're doing a sharp curve project, you can leverage this research as well through the same or similar strategies. I was fortunate enough back when I was at Georgia Tech, I started the research there and been able to implement it into practice. So it's been kind of a interesting process seeing it all the way through. So what that curve tool that Georgia Tech developed does is it finds the point of curvature and point of tangency using a shapefile on all of the curves on our state road system. We're doing off-system roads next. That's currently under development. If there's some curves you want, let me know, because we're currently processing that off-system as well. So not only does it find all the curves, it finds what curve signage is required, recommended, and optional in the MUTCD. The old MUTCD, I know that changed a little bit. We'll have to update that. So that just takes into account all that information on the curves and computes that data. So what's included in this data set? We have measures of exposure for crashes, curve length, as well as annual average daily traffic on those curves. That just comes from TDA, just spatially associating that to the curves. And then risk factors, curve radius, the deflection angle of the curve, the speed, both posted and advisory speed of that curve, roadway division, meaning is there a median, and then ball bank indicator. Now, what is ball bank indicator, you may ask? That is a measure of the lateral forces on a curve. We have it available on every curve on the state route system and off state route system. We just haven't associated with curves yet. And that was done by actually having some GDOT employee drive every single curve in Georgia. I would dread to have had to have done that, but we don't want to keep doing that. We'll shift it to another approach later. I'll talk about at the end. It's commonly used to establish advisory speed limit, what that yellow curve warning sign should say on it. And in my thesis back in college, we proved it as a surrogate for roadway departure crashes. So the traditional ball bank indicator device, the measured lateral forces, brought one in with me today, is simply a ball within a glass tube. The more lateral forces, the higher the ball bank indicator reading, the higher the angle, the more risk of a roadway departure. Portland, you can pass that ball bank indicator or BBI around. Nowadays, though, no one uses a tube device. You can get that data on a smartphone or some sort of electronic device. It's kind of outdated. You can see ball bank indicator on a free body diagram. It is a combination of the angle between the resultant forces, meaning the combination of the centripetal force, normal force, and frictional force, and the angle between that and the force of gravity. So make sure you know it includes mass, velocity squared, and radius helps form what that ball bank indicator reading is. But that angle is not just ball bank indicator. There's also super elevation that plays into account, as well as vehicle body roll, or the lean in the vehicle, as you can kind of indicate by the vehicle leaning towards one tire there. When we collected that BBI data, though, it's not just 1 point per curve. You have hundreds of ball bank indicator readings per curve. Every road was driven twice, and every point that they could get as granular as possible collected a BBI reading. So what we did is we took the 95th percentile highest value of that ball bank indicator reading. So nearly the maximum. What we didn't do is take the maximum value. That's because if you hit a little bump or you hit a stone on the road, something like that, that ball bank indicator reading shoots up, and it's historically known for having lots of outliers. So definitely make sure you're not taking the maximum value if you do see that. Ball bank indicator is not just radius, though. It's not just a proxy variable for radius. What I'm showing here is two different scenarios. One curve much sharper than the other, but you see a much higher ball bank indicator reading, meaning more lateral forces on this curve with a minimal curvature in between two tangent segments. So the curve on the right, it's kind of a windy roadway segment. The drivers aren't really going that fast on it. You're not getting that much lateral force, kind of expecting that curve. It's in conjunction with many others. While the curve on the left, that curve kind of catches the driver off guard a little more, and there's more lateral forces. So there is some overlap with radius. Radius obviously influences ball bank indicator, but remember that centripetal force, which plays into ball bank indicator, mv squared over r. It takes into account driver behavior and how fast people are actually going on those curves as well. It's really important to note that we are not just doing this for all types of crashes. This study focuses on rural roadway departure. That's because they represent the vast majority of fatalities on curves. About 40% of our fatalities statewide are roadway departure crashes, just single vehicle crashes. Another 20% are pedestrian. So I always, I feel like we emphasize the intersection a little more than it needs to be. So when we look at why we have to focus, it's because these risk factors don't always have the same correlation to all crash types as they do to roadway departure crashes. So what you're seeing here is the predicted crashes on the y-axis and ball bank indicator reading on the x-axis. We'll see a prediction model for all crash types in the light gray, and then the dark gray for lane departure or roadway departure crashes, inclusive of head-ons where you depart the lane, but not the entire road. So what you're seeing is as very low ball bank indicator readings, you see lots of all crash types. There's intersections, driveways, your rear ends, angle crashes. Really has nothing to do with ball bank indicator readings. Likely if you have a sharp curve, that's not where you're going to put an intersection or a driveway. So ball bank indicator is not playing into those type of crashes. But as that ball bank indicator reading gets higher, the curve's getting sharper, catching people off guard a bit more. That gap closes. The vast majority of all those crashes become roadway departures, and ball bank indicator shows a really strong relationship with those. So moving on to the risk assessment we did in our analysis. Using a safety performance function, this is what I developed in my thesis and have been able to implement it into practice. We built a crash prediction model. Would love it if everyone leveraged this as well. Predicting roadway departure specific crashes based on ADT, ball bank indicator, radius, curve length, and roadway division, or presence of a median. We then categorized all of our curves into 5 different risk levels. The top 5% being your highest risk curves. Then you have your 75 to 95th percentile, and then 25% buckets after that, and associating a dollar value to all those curve risk levels as well. We didn't stop there. That's being a bit too proactive, so we wanted to gauge the observed crash data as well. 50-50 split between both observed crashes, what's happening on the curve, as well as predicted crashes, what could happen on the curve. Roadway departures are random and rare on individual curves, but still one of the most common crash types or fatality types statewide. So just trying to be a little proactive and reactive, not ignoring what happened. That expected crash frequency weighing observed and predicted was what we used for our prioritization. If you're wondering why I didn't use empirical Bayes method, If you're familiar with that, it's because I don't agree with it philosophically. Ask me afterwards if you're curious about the technical details of that. So what that looks like is we've categorized all of our curves into risk levels. Here's a sharp curve and a string of sharp curves in District 1. You'll see those green dots represent crashes, roadway departure specific crashes. When you have a lot of crashes on curves, those are going to be a risk level 5, your top risk level crashes. No prediction model is going to take away from those high crash frequency segments. But then you have other segments pretty close to them, but people are already departing the road earlier at say this risk level 5 curve here. And then when they hit these risk level 4 curves, they'd already departed the road, so they weren't getting the crashes. And we have seen where we put high friction surface treatment down and it just moves the problem to the next curve. So this is something we want to avoid. And that's why it's really important to have that proactive approach, engage all of the curves on it in terms of risk. So I'm going to turn it over to Cortland, and he's going to talk about on these risk levels, what kind of improvements we're doing.
All right, thank you, Ron. Can you all hear me? Awesome. All right, so safety improvements. First and foremost, we're going to look into improve our curve signage, so bringing that up to MUTCD compliance standards. Also installing advisory speed limit silence on our curves where warranted, and also just not just doing the recommendations, but really making sure that we're improving curve safety beyond just going against the recommended standards. On our more severe curves, we're looking at installing flashing curve warning signs. So to make sure that the driver's alert has a visual cue beyond just the sign itself, but actually having a flashing warning sign ahead so that it can see and be aware that a more severe curve is up ahead. So, and I want to make sure I emphasize this. So we are doing a pilot on this because we understand that this is not MUTC compliant, but this is a trial based on one of our high risk curves that we're trying to do, which is with this curve ahead pavement marking. We want to see how much this actually implements and affects roadway departures at these high risk curves and see if we can reduce those departures and fatalities as well. Also, we're installing on our high risk curves slow or curve ahead warning pavement markings as well to, again, alert people to what's going on so they're aware of the advisory speed and what they're about to drive into. Again, advisory speed markings as well. So 25 miles per hour or more, just so they know there's no, basically, we want you to be fully aware of what you're doing, how we want you to drive, how we want you to handle the curve as you're maneuvering. So these are my favorites. I've actually seen a couple of these actually installed already in our state on a off-system road. So the visual cue for the speed bars, the idea is to make it seem like you're going faster in the curve, so that makes you slow down. So even though you may be doing 25 miles per hour, it makes you feel like you're doing 30 or 45. And I've seen this in practice where I was doing the advisory speed limit myself in the curve, and I slowed down to 10 miles per hour because it just felt like I was going faster than I was actually doing. So that's the idea. We want to give the illusion of your speeding so that you can slow down even more. So that, again, gives you the opportunity to make more conscious and rational decisions while you're navigating the curve. So one of the treatments that we talked about, Ron mentioned already, which we also have a visual for as well, is the high friction surface treatment. This particular treatment has, we will install on our more severe curves, like our risk level 5 curves, where we're looking to install this at and 4. With that treatment, what we're trying to do is create more friction so that you have more opportunities to slow down, you can navigate the curve easier. But with this particular treatment, we see that after that top layer rubs off with the epoxy, it becomes less effective in this particular countermeasure. As you can see, these CMS have been directly developed for Georgia, and we can see where with ADT correlations and also this type of the crashes that we see being affected by high friction surface treatment. So you can see just by these numbers alone what this countermeasure can do and how effective it is. So the treatment that we're going to do is the lightweight aggregate, an alternative friction improvement. At least 1/5 of the cost of high friction surface treatment. Long-term friction value is comparable to the bauxite that is used in the epoxy, and there's no epoxy base in it as well, so that helps. With the lightweight aggregate, so if you can look here, that blue line that just drops straight off of that sharp decline, that's your high friction surface treatment. After that top layer rubs off, that's where the friction value drastically drops off because you're just left with that layer of epoxy. So it's not effective when in terms of improving friction on those sharp curves. That's why with the lightweight aggregate, we want to go with that. You don't have that epoxy bonding factor, so it's a little bit more durable, less cost, more cost effective, and also with that high friction surface treatment, and also with these metrics right here. This was done on a track in Auburn. For all my Auburn grads, you guys might be familiar with that track that's out there, but this is not in a real world application. This is in a very routine tested track site that these numbers come from. So this is not real world applications, but still realistic as close as we can to real world application with the high friction surface treatment. That's why we're going with the lightweight. Typical designs. So for risk levels 1 and 2, we're going with your typical signage, restriping with thermoplastic and reflective pavement markers. For risk level 3, again, we're gonna add in that advisory speed limit pavement marking as well as the advisory speed limit sign, which are typical chevrons as well. Risk level 4 is when you start seeing that high friction surface treatment being installed. These curves are more severe. You have that kind of also like you saw earlier with that continuous from like a risk level 5 into a risk level 4, making sure that that continuous of high frictions of lightweight aggregate, not high friction surface treatment, but that lightweight aggregate, making sure that that friction control is still there throughout the entire curve. So with this risk level, you see again, you have your advisory speeds, you have your chevrons, but we're adding now that friction treatment. Same with risk level 5 now. With risk level 5, this is where you will see the flashing warning sign for the advisory speeds, because we really want people to be aware of how severe this curve is and ensure that safety is met here too. And then this is what we're doing for our optical speed bars. So we're really putting this in when you have that 20 mph difference between posted speed limit and the advisory speed limit. So for this example, you have 35 mph advisory speed, but you have a posted speed limit of 55. So to ensure that that advisory speed is adhered to, we're installing optical speed bars as well. And now this isn't dependent on the risk level. This is more so dependent on that speed limit gap. So if you're on a high-speed corridor on one of our state routes, like a 55 mph, 65, where you see those large gaps is where you also see these optical speed bars. Same here as well. And then we're not just doing this in theory, we are actually implementing these already in our districts. We have I think it's like over almost 10,000 signs that we're installing right now throughout our districts. And also we have some upcoming projects with curve warning sign and that friction treatment that we're talking about as well. So we're not just talking about this, we're actually putting this into practice so that we can see this come to fruition. And then I'll turn it back over to Ron for future uses.
Cool. I'll just add one thing. If you're wondering why we only constrain to that flashing beacon and not flashing chevrons or speed feedback signs, maintenance is a concern with all the electronic devices. They all need signal permits. So if you're a local government and you guys want to do it on your own local roads, I encourage you to do so. But from a statewide level, the maintenance really is a challenge for that. So future use cases. I mentioned at the beginning that someone had to drive every curve to get that ball bank indicator reading. I don't want to do that again. That sounded awful. There's no reason we can't leverage crowdsourced data or some sort of continuous devices. So what I'm particularly interested in is big data coming from connected vehicles related to friction demand as well as friction supply. Friction demand meaning the lateral forces on the vehicle, and friction supply meaning how much friction is actually on the existing road. This one company, Naira, there's competitors as well, that sells lateral force data on curves through the Eastern Transportation Coalition. We're exploring that feasibility of buying that for the entire state to leverage as well, and kind of replace that value with a ball bank indicator when we go to do this analysis in other districts or on urban segments too. Alternatively, you can get actual friction data on the curves. Right now, the way we collect friction data is by putting a device on the ground and stopping all traffic. You can get that from continuous friction devices. Scrim is one of the companies. You'll see a kind of example trailer that we have a little mini 3D printed model of, one more prop, of course, to share. And what that does is gives you the friction on the curves. And that'd be really great for before-after studies. to see, did that friction actually improve once we installed it? How is it going over time? As Cortland said, there's that epoxy layer. We want to make sure that there's not just epoxy on the road and once that coarse aggregate on the top falls off, because then that could make things worse on our highest risk level curves. So that's why we're switching to that lightweight aggregate. And that's why the existing epoxy based high friction that we have out there, we want to make sure we're monitoring with at least one of these two alternative options of friction measurements or connected vehicles, and really do want to emphasize that. I think that's extremely important. So back to those three key takeaways I brought up at the beginning. So remember, we did a systemic study. This was on all of the state route rural curves, focusing on roadway departure crashes specifically. We used crash data in conjunction with proactive data sets from that curve information extraction tool. This was for state routes. We're building this for off-system routes as well. It should be coming up soon. The project is already kicked off. And then we leveraged all that data to categorize curves into different risk levels and program different countermeasures depending on the curve risk. So thank you guys very much. I'd love to take any questions you have, I think at the end of the presentations.
So I'm gonna introduce our next speakers. Molly, Kylie, and Quinn are going to talk about key design considerations for at-grade rail crossing. Molly Turner began her career in transportation as a roadway co-op while attending Georgia Tech. She has since gained over 8 years of experience across various roadway improvement projects, including railroad at-grade crossings, bridge replacements, roundabouts, rural and urban widening, and new alignment corridors. She is a project manager at Benesch, working on transportation projects throughout Georgia, as well as managing the GDOT Railroad Safety Program for Norfolk Southern at-grade crossings in Georgia. Molly is currently the chairwoman of the ACEC Junior Board and serves on the GPTQ Subcommittee for Roadway Design Policy. Kylie Vacco is a graduate of Georgia Tech with over 7 years of experience in roadway improvement projects. Her expertise spans projects that include bridge replacements, railroad at-grade crossings, urban design, and sidewalk enhancements. Currently, she serves as a project engineer at Benesch, focusing on transportation projects in Georgia. She is a roadway engineering lead on Benesch's GDOT Railroad Safety Program, helping to deliver projects that improve safety at at-grade railroad crossings across the state. Quinn Knapper started his career as an operations data analyst for Georgia Tech Research Institute. After 4 years of contributing to data-informed decision-making at GTRI, he has since gained 2 years of dedicated grade crossing engineering experience with Benesch. He currently works with the GDOT Railroad Safety Group to help deliver the state's Section 130 program, evaluating, prioritizing, and implementing safety improvements for at-grade crossings in Georgia. Please welcome Molly, Kylie, and Quinn.
Sorry for the tongue twisters. Awesome. So like Susan said, myself, Kylie, and Quinn, we're here to talk about railroad safety. And really what we want you guys to get out of this is stuff, design elements you can incorporate into your plans that make these crossings safer across the state. So with that, why are we here? This graph shows the last 15 years of crash data broken into 5-year segments. And these are the number of crashes for all users of the road facilities. So that's vehicles, bikes, and pedestrians. And then in light green, you'll see the number of fatalities. And really just kind of what I want you to get from this is that it's not really getting better, right? The number of crashes is going up. So again, it all comes back to safety. It's the title of the session. It all kind of makes sense. But I'm sure a lot of us have been on projects where we do everything within our power and sometimes outside of our power to avoid the railroad, right? Like don't touch it, cut your limits, right? Everyone's nodding. Okay. And so really we're trying to give you some easy things that you can implement, whether that's just a couple signs that you put in, some pavement markings that can make these safer across the whole state, because we don't have funding to touch all of them, but with all the projects going on near them, we can hopefully improve the safety. So just a little background. So the GDOT Railroad Safety Program exists under the Office of Utilities, and Jason Mobley is the state railroad crossing engineer. So we have one of the consultant contracts. There's a couple others as well. And the main goal is to reduce or eliminate hazards associated at these at-grade crossings. And the main way we do that is reviewing the crossings through a multitude of ways. So the first is reviewing all construction work program projects. There's the tongue twisters. With railroad coordination. So you'll see railroad safety people sitting in on your CTMs, your PFPRs, your FFPRs, and leaving comments on your plans. We identify projects to be funded with our Section 130 funding, which I'll get to in the next slide. And then just addressing concerns from local governments and local residents. So mayors call us, send emails, you know, a semi truck got stuck on a crossing, something bad could have happened, what can we do? And we'll go out there and visit it and hopefully do some quick solutions. And then residents, just as ourselves, if there's any local problems, can report them as well through a few different options on the GDOT website and get them addressed. So from assessing them, we'll come up with recommendations that can have a variety of solutions. From installing new warning devices, upgrading existing warning devices, closing crossings if that's the best option, improving geometry, simply updating the sign marking, doing a full grade separation, or again, just upgrading the surface crossing surface itself. Ooh. Okay, Section 130 is a bucket of federal funds out of FHWA used to fund railroad, highway, grade crossing safety improvements for each state. So every state has a Section 130 program. They all run a little differently. We're very familiar with the Georgia one. Don't ask us any other state questions, please. So like I said, GDOT partners with local road authorities for roadway improvements. And the crossings are added to the list on quite a few factors, but the numerical value is called the Hazard Index Formula, or HI. And that takes into account crash history, traffic counts for specific types of vehicles, such as school buses. If the school buses have to start or stop for the crossing, it increases the hazard index, existing site distance, future growth, and existing roadway conditions as well. So now Kylie is going to take us through some of the national and state standards.
Okay, thanks, Molly. So this very creative slide that I put together is very detailed. I'm going to go over first the manual and uniform traffic control devices. Anything relating to at-grade rail crossings can be found in Chapter 8. So these are commonly seen signs. I'm sure we've all seen them on the roads, but just putting them up here for your awareness. I'm going to move into the Georgia state standards. So Georgia has a few construction standards and details relating to at-grade crossings. So I understand you cannot read this one at all. This is 9024A. So I'm going to talk about a few key aspects on this one. I'm going to zoom in. You'll find this at the top of 9024A. This relates to the guidelines for advanced placement of warning signs. So the table that you see there is derived directly from the MUTCD, and it basically provides guidelines on where to place those advanced warning signs. So when placing the W10-1, which is the advanced railroad crossing symbol with the X's and R's and circular, there's two types of criteria that it depends on. It's dependent on speed and then the condition of the crossing. So there are two types of rail crossings. One is active and the other is passive. So I'll go over active first. Active crossings are any rail crossing that has gates, lights, whistles, all the equipment. You can find the distances in column 2 up there, that middle column. And then there are passive crossings, which are any rail crossings that do not have gates, simply just have the railroad crossbucks. So depending on speed and the condition of the crossing, that's where you will place the railroad highway pavement symbol and the sign. I will note that the values in this table are minimums. So if you do not meet the minimum, you will be required to write a design variance. And they're not exact values either. So you can place a sign further if there is a driveway conflict, utility pole conflict, that kind of stuff that we've seen before. And then this little diddly is also on standard 9024A. in the top right-hand corner. Just want to bring your awareness to this one as well. This talks about the placement of W1011A and W1011B signs. So those signs are the signs that tell you you have X distance between your vehicle and the tracks. These are commonly placed when there is like a stop control shortly after the crossing, where it's potential for vehicles to kind of queue up on the tracks and lead to dangerous situations. In situations like these, we also tend to use R88s, which are the do not stop on track signs, just another measure to kind of keep drivers from queuing up on the tracks. Okay, now this detail, very legible, is 9025A. And again, I just want to bring it to your awareness so that you know that it exists. This detail prevents open medians at grade rail crossings. So oftentimes we see this in the form of two-way left-hand turn lanes. So this kind of keeps drivers from maneuvering around the gates. And this is just a draft design variance that I've pulled to kind of better show that concrete median and kind of how it would work. There was previously a two-way left-hand turn lane there. Okay, moving on from standards and details and all that fun stuff, I'm going to talk about the diagnostic team investigations. We call these DTIs. I just want to bring this to your awareness because the new version of the MUTCD kind of drops this term a lot, and I personally wasn't familiar with it prior to this. So a DTI is basically a field visit where a group of experienced individuals, knowledgeable in multiple disciplines, will go out to an at-grade rail crossing and kind of evaluate it, evaluate how cars are moving, the safety of the crossing, all of that. So you'll have signal engineers out there, roadway people out there, rail people out there, as well as local stakeholders who are interested in the crossing will all come out, evaluate it in the field, and then you'll kind of do a post-field review and generate recommendations on how we can make that crossing safer. All right, now I'm going to walk through a few key design elements that you can implement if you have a project at an at-grade crossing. The first one I'm going to start with is sidewalks. In the images on the screen, you'll kind of see what is commonly found in the field. You'll see a sidewalk that just conveniently ends right before the crossing and then picks up right after the crossing. We recommend sidewalks continuing through the crossing, more so the image at the top there that you will see. The pathing should be designed perpendicular. That's kind of what the green line is portraying there, to allow all users to cross the tracks. So think bikes, handicapped people, preventing people from getting, yeah, I love the thumbs up, getting stuck in the tracks there. Another thing to consider is when designing sidewalks at grade rail crossings is the counterweight on the rail gate. So behind the gate, there's a counterweight that kind of takes up space. You just be in mind, you want to have enough distance between that counterweight and the pedestrians and the sidewalk and using all that. And this is another version of a sidewalk, not as commonly found. The image is pulled directly from the MUTCD. This type of pedestrian gate is used primarily for like shared use paths or trails. One thing I will point out about this image is that the MUTCD strongly recommends that there's an escape route for the pedestrian. That's what you kind of see up to the left there. That way, God forbid, someone gets stuck between the gates and the track, they have an emergency escape route through that. All right, and then the next one I'm going to go over is delineators. So these images kind of show examples of some projects where we put in delineators before. The 718-399N Love Street, those are centerline delineators. Typically, those are used to prevent drivers from driving around the gates. And then in the image on the left, you can kind of see clear edgeline delineators. Typically, those are used when there's not a whole lot of pavement over there, a soft shoulder, etc. And I'm going to pass it back to Molly to go over some more examples.
Okay, so we're going to touch on site issues in two ways. So this first one, this is a photo from a crossing in, I believe, rural Georgia, if I'm remembering correctly. And one thing you might notice is it looks like there's no advanced warning signs at all. So really all the drivers have is that pavement symbol on the ground to warn them of an upcoming railroad crossing. Even the flashers are blocked. So This is just one of those situations where if you're in the field, if this is on your project, or again, if you're just a local resident and you see this at one of your crossings, you know, these are easy fixes to cut the trees down. If it's a utility pole obstruction or another sign, that's a little more effort, obviously. But we would just recommend bringing it up to district or local maintenance. It's already usually in the right of way, so they have no problem trimming the trees back when they can get around to it. So just a little example there of some easy fixes. And then we're gonna talk about site distance. So for GDOT projects right now, it's required to check ISD, stopping site distance, et cetera. But one thing that we see forgotten a little bit is railroad site distance. So this is covered in ASHTO 9.12.4. I personally learned about this when I was studying for the PE, and now it's relevant to my life. So that's fun for me. So this is primarily a concern at passive crossings where there are no train activated devices and the driver is making the decision on whether it's safe. If your site distance doesn't meet this, because it's in the Green Book and not a GDOT standard DPM thing, it's just a design deviation in your project. So as the engineer of record, you would file a design deviation if your site distance doesn't meet. So 2 events that we look at. The first is that a vehicle operator is approaching the crossing, sees the train and decides it's safe to cross. So that would be the vehicle on the far right moving to the far left position. And then the second is that the vehicle approaches, sees the train and decides it's not safe or they don't want to cross and they stop. So that's the far right to the middle position. These are the fancy formulas in the ASHTO Green Book. I'm not gonna do any math here live, but it's a lot of letters and not a lot of numbers, but all those letters are well defined under the formula. So if you just go in the Green Book, all the letters are defined. The one that we see people getting tripped up on, or like a reason they can't check site distance, is the train speed. So to get the speed of any train at a crossing, you would go on the FRA inventory database, and I put the link here. Obviously you can't click it, so just Google FRA crossing inventory form, you'll get there. You put in the crossing number and it pops out this inventory form. I've screenshotted it on the bottom. And in section or part 2.3.A, there will be a maximum timetable speed. So for this example, it's 60 miles an hour, and that would be the value you'd go back and put into your site distance formulas in order to calculate a site distance. Okay, no more site distance. The fourth thing we're going to talk about is dynamic envelope. So this is another semi-simple pavement marking that can be included at a crossing, just to, again, give drivers a visual indication of an upcoming safety issue or, you know, the crossing. So it really usually goes along with what Kylie talked about, that R88 situation with the small storage. If you can imagine a side street on either side of this METCD diagram, there's not much room for vehicle storage or, you know, big trucks, etc. So the METCD has the fancy crosshatch and everything. In Georgia, we primarily just do the transverse bars. Other states are crosshatch only, so it's kind of up to the engineering judgment, or, you know, if it's in a local downtown, they might have an opinion on what it looks like. But that dynamic envelope goes 6 feet from the outside rails on each side. Okay, and the last one I'm going to talk about is low ground clearance. And again, 2 ways. So this slide goes over kind of an existing condition and how to mitigate that. So if the roadway profile is as such that a vehicle could get hung up on it, specifically trucks, we usually install these R10.5 signs and then the R10.5P sign. The METCD says it has to be around for 3 years, but I don't think we propose to take them out usually. So, and the big thing here is that you want to install these where it gives the vehicle an opportunity to turn around. So if it's only at the crossing and there's nowhere for a truck to go other than across, like we haven't improved the safety at all. So sometimes that means going half a mile down the road where there's an option for that vehicle to make a safe decision and turn around. So just a note there. And then the other way I want to talk about is if you are designing a new profile over a railroad crossing, that guidance is in ASHTO 9.12.2. So just a couple sections before the site distance. And really it has great diagrams and how you should do it, but the general guidance is 30 feet from the outside rail. You don't want more than 3 inches of change of grade so that we're not creating these hazardous situations. Okay, now Quinn is going to close us out with traffic signal preemption, and then everyone can go to lunch.
I'm getting a little bit hungry too. Thanks, Molly. So traffic signal or railroad preemption of traffic signals comes into play whenever you have an active railroad crossing located in a spot where it will be impacted by a traffic signal, right? So they're both involved. Typically, the guidance threshold for distance is when you have 200 feet between these 2 situations. But in any situation where vehicles queuing at a traffic signal may reach to the tracks or beyond the tracks, you have a situation where you may need to consider railroad preemption. The railroad preemption should operate in a way that when a train is approaching, the railroad equipment tells the traffic signal that a train is coming. the traffic signal terminates all conflicting phases and then provides a green indication for vehicles queued onto the tracks so that they can begin driving and clear the crossing before the train arrives. This picture on the bottom, it's a quick, simple exercise that you can do on your project to kind of verify that this is happening. So on the top line, you'll see railroad equipment operation, the orange indicating when the flashing lights start flashing, and then it transitions into red to show the gate arm descending. While that's happening, on the bottom, you'll see the worst case scenario. So this is the scenario that the traffic signal takes the longest time to respond based on which phase it's currently in. So you'll see that it terminates all the existing phases from green, yellow to red, and then it provides a track clearance green with enough time for any vehicle that's queued onto the tracks to clear the tracks. Typically on that first section where it goes orange to red for the railroad equipment, that takes 20 seconds. That's typically what we see in Georgia. As you can see on the bottom, it can take more than 20 seconds for a traffic signal to terminate phases and then clear vehicles from the track. So that's where you'll see that blue box. The blue box is that difference, and it's the additional time required by the traffic signal that's not already there in order to safely clear vehicles from the track. You'll hear it talked about different ways, but the Texas Department of Transportation has a lot of good information on preemption, specifically Form 2304. It's a nationally used resource for making those calculations so that when you're having discussions and when you're evaluating your traffic signal, you can guarantee and just kind of have a good idea that your traffic signal phasing is respecting how much time you have. Because we don't want a situation to come up where a train is coming, the vehicles that are queued on top of the tracks have a red light and they don't get a green light, or they get a green light without enough time to clear it before the train arrives. We don't want to be creating those situations. Next, I want to talk about preemption type, otherwise known as the information that your traffic signal will be getting from the railroad. As Molly and Kylie both said, MUTCD Chapter 8 discusses at-grade crossings, but specifically sections 8D9 through 8D12 discuss preemption. There's a lot that goes into it. It's a joint system between the railroad and the traffic signal, so there's a lot to consider. But the main things I want to bring up is this diagram of common preemption elements. In typical operation, you have track circuits. These can be anywhere in the railroad, and you have the warning devices in the railroad equipment. These are collecting information about incoming trains or just crossing status. Those are processed in the railroad traffic cabinet, which then sends the information to the traffic signal cabinet. The traffic signal cabinet receives it in the pull box. It's that white box by number 4, which you guys probably can't read the numbers, and that's okay. But that pull box is kind of where the responsibility shifts, right? So the railroad is responsible for sending the information, and the traffic signal is responsible for receiving that information. That pull box is where you want to make sure that you're getting that information. You guys need to talk and communicate so that the information that's being sent is being received. After being received, the traffic signal cabinet will process it and make sure that any and all traffic signal equipment is responding appropriately to clear tracks as needed. That traffic signal equipment can be the signal heads, it can be blank out signs, or anything else. A couple things to keep in mind here. Like Molly said, when you're looking at the inventory, you can find the train speed. Trains can move fast. At passenger rail, you can get up to 80 miles an hour is pretty fast. So what that means is in order to get 20 seconds or even more that you need for your traffic signal, those traffic circuits can be over a mile down the railroad tracks. So that doesn't typically play into our designs because the railroad will take care of most of that, but it's just to know that you have to be aware of things much further away from the intersection, like all. And then the last thing I want to point out is that for traffic signal equipment, you can have railroad preemption be relevant where you don't have a traffic signal. So any situation where you have some type of equipment displaying a stop condition to a driver, so this can be stuff like pedestrian hybrid beacons or anything like that. They're not necessarily traffic signals, but if they're near a railroad track, you can be displaying a stop condition dynamically for road users that can cause queuing onto the tracks. Some of these devices support preemption and some of them don't. So when you're designing these situations, you need to make sure that would it be needed? And if it is needed, how do we incorporate it into design? And are we able to do it? With that, I know we say quick and easy. Sometimes we say simple, and there's all these things that you can do. But in our industry, quick and easy and simple, it's there, but it's not super common. And it can turn complex really fast. Like Molly said, people from the Railroad Safety Group sit on FFPR, PFPR, all the different meetings for construction work program projects. But if you have any questions or something crossing specific, Jason Mobley, the state railroad crossing engineer, he's a great point of contact for connecting with support, as well as more resources and information. With that, I believe we'll open it up to questions for not just our discussion, but the discussion before with Ron and Corbin. Thank you, guys.
Any questions? Yes. There. Sorry, general, yes.
Let's look at the pairing back, active on. Thoughts on, dangerous curves in dense urban areas, I don't think very many of them, but I know y'all being all focused, but, should a dangerous curve within a city or similar treatments or other ways to think about that?
Yeah, I think the same prediction model can't be used because crash frequencies are entirely different in rural areas compared to urban areas. But the countermeasures are just about the same. We've done some quick response projects, so more on the reactionary side of things. We've done the same countermeasures, optical speed bars, speed advisory signs. I think those yellow curve signs we've actually done in District 7. They're on a Peachtree Road, I believe. They're pretty effective, and high friction surface treatment the same. It's not just curves in urban settings, off ramps as well. Even T ramps at signals. People tend to be coming off the interstate at high speed. So any place where there's a large speed differential, it's kind of the same countermeasures, different prediction model you would need to prioritize though. Yeah, I think we're also looking at them in terms of context for pedestrian crossings right now. I think in the METC, it shows it with like near raised crosswalks, but the pedestrian hybrid beacons is another place we're looking at using them too. We have not implemented that yet, so I don't want to give any definitive statements, but we're looking at developing a typical with pedestrian crossing ahead and optical speed bars as well, particularly for trails. Well, didn't you see the slide there? That was crash reductions in Georgia of previously installed high friction from a safety engineer before me, I think when that was installed back in 2017. So we have a lot of after data, and it's particularly good at reducing roadway departure crashes. I will say, you know, I've talked to a motorcyclist out there when I was collecting friction data on curves once, and he was like, "Oh, I love this high friction stuff. I can go so much faster now." It's like, okay, it's not the point. That's not what it's meant for. The kind of thing is you'll see a 50% reduction in crashes. This is not we're not getting 100% reduction. We don't really have countermeasures that give 100% reduction. That doesn't mean it's not effective though. Yeah, so it's constructed in a couple places in the state. It was not really done for the purposes of friction improvements. It's just an alternative pavement, more comparable to just traditional asphalt. It's a chip seal, so it's much cheaper, and it binds to the asphalt. Friction value is lower than calcined bauxite, that other high friction surface treatment with the epoxy. So, you know, when it comes to benefit cost, we don't know yet. So we're going to be evaluating, and that's really why I want that big data to be able to do quicker evaluations rather than wait a couple years for crashes as well. Once we program all the projects, I'd love to get ahead of it and program 1 or 2 projects, evaluate them, and maybe change course and see if we should go back. Exactly. Yeah, and the other piece is maintenance has to go put back the epoxy if they go resurface the road, and often they just can't afford that, or it's not sourced in a very economically feasible ways to get into America versus the lightweight aggregate. There's a distributor of that in North Georgia, so it's much easier to get. And if you're curious, that lightweight aggregate is synthetic volcanic rock. Technically, it's if you're in Hawaii, they don't need it. They can just use the normal aggregate there. Okay, take that one. It's a tough one.
This one's kind of tough, but we're coordinating with our districts to see that they would handle the maintenance. So more so our maintenance group would be responsible for maintaining it. And we'll program it, fund it in terms of having it built, but then the maintenance will go into the districts and into our maintenance group. That's why with the flashing beacons for the chevrons, we're not including those because of that high maintenance cost.
Yeah, and I think one of the things that we're told is maintenance isn't an excuse to not do the standards. It's, a lot of this is standards. We're going a little bit above them as well with some of the pavement markings, but those are the longer lasting ones. There's a reason we took out flashing chevron signs from the project because those are most likely to get hit. And maintenance and our district maintenance was not handled to that capacity, but asset management is really something we're going to have to think about more than just pavement preservation. It's much more than that. It's safety, asset management as well. It's signage, markings, not just pavement quality.
What would you recommend cities and counties that are looking to do some of the kind of like you spoke in your presentation on off-system routes? Having state funding, would off-system state funding be that? Is there any
It's my favorite off-system safety funding thing, I think, because it's within the right of way. That's primarily those off-system safety projects have to be within the curb lines. They handle resurfacings as well. Just right away and utility coordinations. The main ones, you might have to pull out the flashing beacons depending on solar power there, because you might not be able to get utility over there. But at least you get a lot of those other countermeasures to do. So yeah, I would, that's well, I've been working with off-system safety lately, and those are my favorite countermeasures to give to them.
Okay, yes.
Yeah.
That,
It basically turns into like glass. So, yeah.
so it's like that amount of easels is not very common on a road, and it takes 10 years to get there. We put that back in 2017 on a rural road. It can be over 10 years. That's why I say we need to monitor it. It is of the utmost importance to get this data to monitor, so we don't have to go out there with a friction testing device. Our one way of being able to monitor it now is to stop traffic, put a device on the ground and say, oh, here's the friction value. Oh, well, it's awful. I guess people have been dying the whole time. So this would give us continuous results if we did this routinely to be able to say, okay, we need to replace this. And that's really the reason I want to switch to the lightweight aggregate, because it does not, it binds to the aggregate. There's no epoxy involved. And if you take a look at the high friction surface treatment, I'm going to ask for that back afterwards. You can see the epoxy on it as well, and it looks like glass when it's hardened. So.
Right, so the question is, when you're dealing with preemption, can you coordinate with train schedules? And the answer by and large is no. You can look and you can try and coordinate with the railroad to get train schedules to maybe coordinate how you respond to preemption with the train equipment. However, train schedules are fickle. Maybe they aren't, maybe they are, but that's what the railroad will tell you, is that there's not general consistency. So you can perform your own analysis and make your own determinations on when trains will and will not come, and you can use it, but you won't be able to get something that confirms or denies that. And in addition to that, right now in Georgia, we're just seeing a common issue where preemption needs help in general. So before we even get to the spot to where we're willing to maybe try out some new things and determine if train schedules can be used to do efficient preemption, we just want safe preemption first. So making sure that your traffic signal timing respects the amount of time you're currently getting from the railroad is our top priority. But there is analysis to be done on train scheduling. It's just not something that you'll be able to get concrete information on. Yeah, yes. Over time, you should be able to record the preemption calls you're getting from the railroad to determine how often, how frequently, and how long. Yes.
We have time for 3.
Yes, I'm glad you asked. So this is something that's new in the new MUTCD. It's called supervision, preemption supervision. So this is something that's in the railroad track circuits. And what this means is that if there's an error in the railroad track circuits, what typically happens now is it'll tell you that a train's coming. It'll drop the gates and the traffic signal will receive the signal and will go into preemption. And so you enter this situation where the lights and gates are flashing and the gates are down for extended periods of time when the train is not coming. And all the traffic signal knows is that a train is coming. Can be problematic for driver behavior. But supervision allows the railroad track circuits to tell the traffic signal why it failed. And what this can do is instead of saying that the train is coming and the gates drop down, which is safe, what it will say is preemption is broken. And what will happen is the gates will go down and the traffic signal will think the train is coming, but it'll know it's because the circuits are broken. So you can use your traffic signal to do different things when a train is coming versus when the circuit or the preemption is not operating correctly. That's on the train equipment type of things. On the traffic signal type of things, it's just limited to what you can do in your controller. So anything that you can do to monitor the health of your signals and the traffic cabinet, you can do to help monitor the health of your preemption equipment inside your cabinet. Right. It's starting to improve. Part of that is that we showed on that graph that there's that blue section of time, which is in Georgia and typically required that you get 20 seconds. So when a train is coming, you are guaranteed 20 seconds from when you can tell the traffic signal a train is coming and when the train will arrive. That's not enough. Some places you need more, some places you want more. So knowing that balance between what you need and what you want can be helpful in having those discussions. And then the other side of that is that knowing it's going to require upgrades is part of the process. So just knowing your information and what you need to know when you start having discussions with the railroad on, hey, 20 seconds is enough, we need more. You can have more intelligent and you can have more productive conversations by coming in with those separate knowledges.
I'll just add too, that's why we put Jason's email at the end of our presentation. So like I said, the Office of Railroad Safety isn't like a super known about office, and it's like, I don't know, maybe you agree, disagree, whatever. But he's the point of contact where if you need help getting that information, he can assign it to the consultant. So we do the Norfolk Southern crossing, someone else does CSX, and another consultant does everything else. So we have monthly meetings with them that we can ask these questions and make sure we're getting you guys answers. So that's why we put his email up. Please reach out and he'll assign it to the proper team.
Last question.
didn't see a lot of touch on the presentation on that, so it's kind of curious if that's something you kind of wait from, or that it's still very much a tool to do a lot of future.
So that's an interesting question because I definitely think of roadway departures from something like rumble strips and rumble stripes, different from curves. Those are more meant for falling asleep, distracted driving. Honestly, on sharp curves, they are not a proven safety countermeasure. Even center line rumble strips, there's studies showing increases in crashes from them. I'm not sure I believe those studies, though, to be honest, they're not proven, they're not very high star rating CMFs, but exactly. So, but regardless, we just updated our rumble strip policy. If you guys are curious, it's more multimodal friendly to make sure we have the full width for cyclists on shoulders, particularly those rural shoulders. That's extremely important. Making sure you have that gap pattern and the rumble stripe, or I guess we're doing the raised markers on the stripe. So within 6 inches of the pavement, it has similar, what's the term? Audible decibel readings in the in vehicle decibel readings. So we think it's a great countermeasure. It doesn't have to be the 16-inch rumble strip in the shoulder to be effective. Yeah, so I encourage you all to check that out. That's in the design policy manual now.
This concludes our last technical session. In 13 minutes, we're gonna have lunch next door. So, and be sure to sign in the sign-in sheet. And thank you for coming.
Again, friction surface treatment back.
Ron.
Yeah.
A question.
Yeah.
Is that because I have super comments for you. So you know, I asked them someone takes guys are really out there. Yeah, now it's like, how do we get milepost down? Sometimes we're just trying to. I think I'm gonna email you. Yeah, they had it. I saw them back here. That's all. Yeah, I'm emailing it. And so, okay, I'll email them.
That's how.
I was surprised, I guess.
Yeah, I think I'd like to replace it with I think in rural areas, we don't have it all the time, but especially in urban areas. I think
We sent a county request, there's speed about 20 miles per hour, when there's a lot of crashes on that lane. There's a lot of crashes, because I'm on speed road. Yeah, fifth, I mean, I haven't.
So-
I thought it was like 8 are probably higher than 12.
it's that driver.
If I'm looking at it, sites may say all that, just trying to interact, if I have a on faster, then that might change that, oh, I should use posted at 9 things.
You think that would change spacing? The message that works would change.
Yeah.
Oh, no, maybe.
I think it's based on. If it's only 5, and let's say it's not 4, but if you're below 55 or higher than 55, the advisory speed is higher than maybe you space those a little differently or or you go from because I guess it's 40 advancement to the advisory speed difference. So if the 85th is higher, then that separation is higher. It's like the difference is in you still have to practice their installing stuff. I guess if I have that differential now higher, I might, okay, I should basically that's 200. So, you know, because people are driving faster. But then the other one is the cars are probably slower, so then.
Yeah.
Molly, right?
Nice to meet you. Spacing. Yeah. I could see that. But I mean.
Yeah.
So where's your office?
Do a new prediction model, we can calibrate the new prediction model to the.
That's right next to, Eli. I used to work at
Yeah.
Yeah,
Yeah.
that's right.
For the,
Pretty conveniently located,
uh,
although I guess all of
low
them.
speed roads that essentially
Okay. Wow, using the printer.
obviously, like.
Printing all companies.
Those,
Cool.
I guess if you thought to install.
Great, yeah, I like the pedestrians. I was gonna see if like
So.
that presentation you had, the design.
Of last year's, it's that's not as much.
The concrete median.
Maybe.
Okay, yes.
Like a draft.
To like slow down going to those curves.
Yeah.
I guess like, I don't know if y'all consider speed tables.
So, yeah, it's fine here.
On it, but at least they're once you're swanning. Yeah, because I guess that's. Gotcha.
It's just like the center being.
I know Jeff.
Okay, interesting. Well, we'll be pushing for. I think we're gonna hopefully eventually the city of Atlanta start making green.
That's probably great.
Yeah, because I noticed that was like, I was like, it's.
And the MUTCD is they're trying, but they're not.
Yeah, but it's on.
It's just like, wow, let's slow it down. Yeah, the crashes.
Yeah.
It's kind of crazy to see.
City will have much about
I
that,
think
you
that
know.
could be, we see some.
Yeah.
Cool, thanks, guys.
Yep.
Nice to meet you.
I know, it's like,
See ya.
because it's like, you can't. I know that's okay because you don't want to install those without like, I don't know, you could run into a speed table and it's like you're not expecting it, so it's different. Hard to install.
I can see it now.
Yeah.
I'm not someone specialized in neighborhood traffic now, you know. I think that.
Really easiest.
Countermeasure.
I briefly worked it.
Thank you.
Yeah, again, if you just need to know the crossing ID number.
How do you find that? I've had.
GeoPie, so there's secret layers in GeoPie. It's like a stack of things on top of each other. If you click that, you can turn it into road crossings. But also, if you have a project that has it like the PM, it should be in the
On road.
program.
We've worked with Quinn before, and so, like, we were wondering how we kind of got some of his stuff, so, yeah.
Yeah, I was on a meeting, which is our policy, and it was like, well, how would we ever check site distance? We don't know the speed of right? I was like, well, we do.
We do know
Yeah,
it.
very rarely it'll be like,
Yeah.
but
Thank you.
Thanks for your presentation.
thanks for coming.
The first project was great.
Thank you.
I need my.
Yeah, it's been a big weekend for me. I'm ready for it now.
Wait, can you just send me a screenshot of that in Teams? Is this your computer?
This is my.
Yeah, just send me a screenshot of it.
Easy.
It's too on the right.
Yeah, that's why if you Google FRA crossing in New York, it'll come up. It looks like a website that hasn't been updated since
Okay,
nineteen
I think,
seventy.
I think my question was like, how do you find the crossing number? That's,
Okay.
that's been where I.
That should be. Yeah.
Want the entire presentation? Because I can email it.
Are you okay sharing the presentations? Yeah, I mean, please.
I think we're
Yeah.
talking about after.
There
we
are.
are. Okay, for now, the snip will do.
Okay.
But yeah, I'd love the
Thanks.
presentation. We're the SIG up. So we have preemption everywhere, so it's been like, kind of cool to work with you guys, so, yeah.